Stéphane Duguet from Thales. Thales is a French multinational which has about 90,000 people operating, working in 68 different countries. Thales is really a technology or engineering company that designs and then operates systems. Thales is very active in aerospace, where they do, for example, air traffic control. They are one of the first, I think, if not the first, in satellite designs and operations. And as far as Hong Kong, you will see them in ground transportation. They work a lot with the MTR and digital identity and security. So, for example, the new Hong Kong ID cards are manufactured by Thales. And another big part of their activity is defense, which is completely kept separate and ring-fenced. Thales invests about €1 billion every year in R&D, and that's about 5% of their revenues. So engineering, technology, science, all of that is really core to their success. Stéphane has been in Hong Kong for about 10 years. He's worked for a number of companies, most recently Cathay Pacific, and now Thales for, I think, about 3 years, if I'm not mistaken, where he's head of research, technology, and innovation. So Stéphane is going to take us through how Thales uses artificial intelligence, and will tell us more importantly, I think it's going to be a very different style of talks compared to what we have seen and heard before. It's going to be a lot about organization management and how Thales builds and maintains a culture of innovation. So Stéphane, whenever you want to start, it's yours.
Thank you, Emmanuel. Welcome, everybody. Thank you for joining us tonight. So yes, I will present what's two parts, what Thales is doing in terms of machine learning AI in general, on how we manage innovations. So no technique for my part, only a PowerPoint slide, sorry. So first, I will redo a quick introduction of Thales with a picture. So Thales, we are helping our customer master every decisive moment. Decisive here is an important keyword. It's companies that focus on decision support. So helping a customer make decisions like when to stop a train, how to land a plane, this sort of decisions. So this we already had. So a lot of employees, a lot of countries. We invest a lot in self-funded R&D. So 1 billion euro, so 4% of our revenue. And that does not include the R&D funded by customer. We focus on 5 different areas. Digital identity and security. So everything's related to IDs or encryptions, transaction encryptions, for example, for banks. We have a big part of defense and security. Aerospace, everything related to planes, air traffic management, or electronics inside the plane, or EFE, radar, distance radar, this kind of things. Space, mostly satellite design, satellite parts. On ground transportations, that is split in urban rail and mainline systems. And it's a big part of what we are doing here in Hong Kong, like Emmanuel presented. So in Hong Kong, we have mostly ground transportations on digital identity and security, and we are 300 people. So our missions across these different areas is sensing and data gathering, and data transmission and storage, data processing and decision making. So that's a full scope of information acquisitions, processing, and decision taking. And where we invest the 7 billion I mentioned before, it's in connectivity, artificial intelligence, big data, and cybersecurity. So the 4 pillars where we have this investment. So now about artificial intelligence. Don't hesitate to post questions or interrupt me during the presentation if you have something direct you want to ask. So Thales in research technology in artificial intelligence. It's 30 years of research with neural network in the beginning, expert system, and then constraint logic, programming, fuzzy inference, constraint programming again, multi-criteria decisions in 2000, semantic networks, multi-agent, evolutionary algorithm, big analytics, big data, video analytics, information fusions, knowledge-based reasoning, and now more on deep learning, active learning, transfer learning, GAN. And I will speak more in detail after what we do today is more in explainable AI, trustable AI. So we have 150 AI experts, three-fourths in France and one-fourth in Canada. And we are always hiring, like having 50 posts open. But we have strong competitions from the GAFAM for this type of positions. Next, the technical pillar, sorry. So about the technical pillar we present before, so connectivity, IoT, big data, artificial intelligence, so it's data collections, knowledge, learning, and evolutions with a secure system, so data security, security of communications of the applications, and all that to go to autonomy. So that's one of the main target in all our different business is decision taking made by AI. And for that, we've done multiple acquisitions in connectivity, big data with Guavus, that was more telecom, big data for telecom initially. Cybernetics, that is complex decision taking. Vormetric and Cisco as cybersecurity systems. We worked also with a startup with different ventures. We have put in place a digital factory that allow us to transform the research we've done in product, a digital product. And like I said, we have a research center in France and in Montreal with 150 people dedicated to AI. So the difference we see between what we are doing on other company like the GAFA is we are dealing with critical systems. So mainly it's systems that if they are failing, when we call what we call safety critical, it can result with injury or death of people. Then mission critical system, where if there is a failure, we have a problem with a goal on our activity. On business critical systems, it's a failure that impacts the business, so less important. So consumers, so we have different data between the two. GAFA will be more open data, personal data, IoT data. So that's consumer AI, but for critical system, it will be data that we need to anonymize. It will be critical sensor, health, on the usage monitoring systems. But we also use the same data, the open data that we can have on the consumer AI. Storage, we use public cloud, but we need also a secure private cloud or government cloud to store this data. The computations, we are looking at edge computing or fog computing, not only about cloud computing. On the goal is predictions, optimizations, decision support, planning, and collaborative systems. In terms of security, we need certify with a very high level of cyber security protections. And we need what we call trustable AI. So who can provide it? So the consumer AI is done by many different companies. I don't say Thales is the only one that do critical systems. We have also competitors in this space, but just to highlight, there is a difference in the term of AI done for consumer than for critical systems. On this difference is related to 3 points here: accountability, so behavior decision explanations, the possibility to explain the system behavior. So it's a black box versus glass box systems. We need to understand what's happening inside the algorithm. So the system, we also should be able to explain its own behavior for that. So that the explainability part, we need something that it's hard to get is the compliance, because the system, like I said, critical systems that take decisions for that can impact human lives are certified, and that's perhaps the most difficult part, is to have certifications of the AI system to be sure that it's doing what it's supposed to do. Only that. So that means we need also clear specifications on answer to regulations. So the application of AI in Thales markets. So in aerospace, so the service to airlines, airports, civil aviation authorities. It's flight pattern optimizations, fuel reductions, predictions of unexpected events, managing airport traffic, traffic flow management of passenger, in-flight entertainment for customer service, logistic support optimizations. For the defense part, I cannot talk about it, sorry. For the security business is physical security, video analytics, social media analysis, crisis management, cyber security with vulnerability map analysis, network mapping, log analysis for early detections on detection of unknown pattern, on multimodal analytics on forensic for the cyber security operation center. In space, a bit less, a lot of change detections for the image interpretations with spectrum monitoring and optimizations, on a bit of predictive maintenance. Predictive maintenance is a bit everywhere, in fact. For transportations, so what we are doing mostly in Hong Kong also, so it's traffic flow analysis for the passenger, network usage optimizations, network in terms of transport network, the service to passenger, revenue optimizations, safety and security, again, video content analysis for different parts like passenger density, baggage left behind, passenger laying, prone passenger or violence detections. On predictive maintenance, and for smart city, it will be about mobility, security again, traffic forecasting and optimizations. A big part in transportation will be autonomous train. So it's a train that will be able to drive itself from point A to B, taking in account its own positions. So being able to know where the train is, where he is, at 1 meter precisions, on detecting if there is nothing on the track, on being able to react to different signaling informations. So we can tell a train to go from point A to point B. For example, the initial implementation could be from the last stations to the depot, so the train can go and park itself, because it's part of the trip where there is no revenue, no passenger, so it's help to save time of the people driving the train, so that they don't have to drive the train without any passenger. So the train can go and park itself in a depot that can be far from the last stations, for example. On more across market, everything's related to engineering, so test, analysis, IVVQ, that's integration, verification, validation, and qualifications of the systems. Facility management, health, like I said, predictive maintenance. Everything's related to manufacturing process optimizations. We do also medical imagery, but that is not in one of these business lines. Just one note, in Europe, we are part of a collaborative project which aim to mobilize entire European AI community to serve Europe, creating a collaborative platform around AI. And there is 80 members in this ecosystems for 21 countries, and Thales is one of the big participants. And there is 8 pilot experiments. It's around citizen, robotics, industry, healthcare, media, agriculture, IoT, cybersecurity. It's very wide, but it's a way to foster new use case and development. So that was about AI. Now I will switch to another element that is linked, because a lot of the innovation nowadays are including AI project. So how do we organize innovation in Thales? So we have 3 elements: the research center, the innovation hub, and the digital factories. So research center is, we have 5 in Thales. So the 2 with AI, the one in France and one in Canada, for example. We have 50 academic partnerships, joint research labs. We generate, so for the moment, Thales have more than 16,000 patents. Innovation Hub, Design Center, so it's we have 21 of those, one in Hong Kong. So it's smaller teams that are in each country to be close to the customer, so we can do prototyping with them. On Digital Factory, there is 3. So it's bigger teams that are here to quickly take a prototype and deploy it as a product with the MVP concept, so minimal viable product. And we have one in Paris, Montreal, and Singapore. And they are also the foundations for the digital transformation of Thales, with best practice, the building of a common digital platform, They are where we do the startup incubations also on the digital academy, so how to train Thales staff in digital subject. So we use to measure innovations, we use a technical readiness level that is NASA initially. So there is a 9 step in this TRL. So the first one, the basic, let me do. So that is more related to research. When we have an idea, we do a technology concept, some experiments. So it's more the research level done in the research center. The innovation hub do more the POC, the proof of concept, the prototyping. So they take technology available on internet or from this research center, and they apply it to a business problem, to pain point from the customer. So here we have a tight interactions with the customer for that. On the last level, the digital factory and the research and development team, they are more here to take a prototype on making a product. And when it's level 9, it's a product that have been deployed and that is successful. So that's how we measure each innovations at which stage we are. We know which type of team we will working on it, and we try to move an innovation from step 1 to 9. So it's also about open innovation. So Thales tried to collaborate. The first collaboration is with our customers. It's where we can get ideas through their pain points. We collaborate with university and research labs when we can find opportunities because there is, like we said, it's sometimes hard to get internal resource, and there is a great people in this university and research labs. And we work with our partners. So a lot of Thales partner or SMEs, because we do a small batch of product when we have hardware, for example. It's not we are not serving customer, but end customer, but more B2B, business to business. And we partner with a startup, like I've shown before. On our methodology, but I will come on that more in detail later, is a mix of design thinking, in startup, and agile. I will skip this one as I will come back on that. So the Innovation Hub, how long do I have still? Okay, 30 minutes. Innovation Hub, like I said, it's a platform for interactive exchange to provide skill on prototyping capabilities. So if you see the diagram, we are in between the research on the labs on the digital factory where we develop the product. So we worked with external customer and partners, so for customer co-innovations, and we work with internal project teams for cross-business solutions on innovation prototyping on our existing product to add new features. So the benefit of a country hub, it's multidisciplinary, multi-business innovations. We have a perception on thinking from different culture, and we expose Thales technology to different markets also, and that allows us to do customer-driven innovations. So the vision is to inspire, to facilitate ID generations, to create, transform inspiration into solutions, to communicate, being closer to the customer, allows also more exchange of ideas, and also trying to do more the wow factor, so to enhance the customer experience having teams very close to the customer they can meet frequently is a good asset. So in Hong Kong, what we are doing mostly is related to intelligent transport, so passenger flow analytics, operation real-time KPI on predictions, on analytic dashboards, so mostly the first part. We do simulations for urban mobility, crowd monitoring in stations, city plan simulations, on smart video analytics with onboard video analytics. So how to calculate, run the machine learning model on edge, so with computers that are on board the trains. So the achievements will focus more on 2020. So we have a product that we call NIAS, it is the passenger flow analytics. So this year we worked a lot on predictions, entry predictions, passenger diffusion matrix inside the network. We've done POC with road traffic detection from the bus ETA. We've done another POC on train operations, KPI, on some dashboard, on alarm dashboard, some AI with intelligent alarm management. So that's it's applying a different AI model, mostly unsupervised to alarm data. We've done tryout on spatio-temporal clustering on some not AI. This one is a mobile app development. So not everything's end up being a product. A lot of the POC don't work out, but that allows us to show also our technical capacity of Thales for the customer to try some ideas quickly and see if it can become useful or not. So more around the innovation hub itself. So it's a place where we have people that on methods that come together. So the people part, we need coders, we need designers, facilitators, and data scientists. We don't have one of each. We have people that can do a bit of both, of everything. Some are a bit more coders or more facilitators, but they need a knowledge in everything on all the methodology we are using. We need the customer, and for us, it's mostly a transport operator. We need them for, we need them for their strategy, their business expertise. We need partners, so the Thales Research Center, Theresis, it's a big data and big analytics in France, the Digital Factory, the Research Center in Canada. We need university, so we done some work with HKU, HKUST, PolyU on engineering school in France. And we need method. Method, so like I was saying, is design thinking for empathy, design, and ideate. Lean startup for prototyping. And then when we start to have a product, something we want to develop, it will be more agile and DevOps. I'll focus on the first two. So it's user-centric development. So we need to talk to the customer. It's very important. If we don't do that, we develop something that's going nowhere. So for the ideations, we use a design thinking workshop with classical methodology, working with a post-it to ideate and select an idea. We use empathy map, so it's to understand the customer, so understand their task, their feeling when they are doing this task, how they are influenced by their colleague, by their management, by their own customer or partners, We need to understand their goal, and very important, we need to understand their pain point. Because when there is a pain point, there is an opportunity. So that's how we do it. It's voluntary blur because I cannot show everything, but just to show you that we worked using Post-it and through a workshop with a customer, we try to understand them better. And then we go through a journey map. So it's we take one of their process where they have a problem, and we try to understand for each steps of this process what they are doing, their actions, which questions they need to answer or they have, what's their happy moments, so what's working very well. Again, what's their pain points, so we can highlight an opportunity for improvement. Same Post-its, workshop with the customer to figure out where there is an opportunity. We need to analyze our gaps. So this is a bit more internal, let's say. We need to understand our solution. Why is it? What the customer wants? Where are the competitors? And where we have the biggest gap between the customer wishes on the actual offer, it's where we also have a place where we can do innovations. So that's one way to do it again. We do an impact map or roadmap. So we map the goals, the actors, what they are doing, the deliverables. So it's why, who, how, what, business goal, key persona, change in behavior, product that will allow this change. And from that, we define what could be a minimum marketable feature or something we can sell to the customer. And that will be built of MVP, so minimum viable product, that's what we call deliver. That will itself will be made of story or features. So we do it again, Post-its. We flag also on this impact map what make Thales happy, so what we want to do. What can be an obstacle, something that will be difficult to do or we cannot do. What makes the customer happy, so the main part he will be interested in. And with that, we can focus on what we need to stop, on which direction we can go. We build after that for the MVP S3 problem solving, so defining background, current conditions, the target, root cause analysis. For the left part, and on the right, we will iterate on a different prototype. So what we tried, the result, on what we should do next. This we do again mostly on paper. No need to do something very fancy. We can write that down. The target is to go fast in the process. We do prototyping with anything. We can do prototyping with a pen and paper, with a drawing, with a mock-up, or if we have data with Excel, with Python or Hadoop, whatever work, so we can quickly prototype. So here, a sample of prototype that was done just putting pictures together. I cannot show in detail, but I can tell you it was a competitor analysis, so analyzes different transport operator across the city. On this prototyping cycle, it's usually 2 weeks. We start by a design thinking workshop for the ideations. Then we have a weekly meetup for kickstarting the week. Every day we have the merge stand-up progress. And at the end, we do MVP usability workshops that will allow us to decide with the customer if we pivot in a different direction because what we've done is not working, or give us a better idea of something else to do, or if we persevere and we try to improve the prototype one step further. So that's the methodology I've shown before. Design thinking to define a customer problem. Lean startup in red with, again, everything is with a customer. So it's always cyclic. So here it's different cycle, but we can put everything together. It's meeting with the customer, trying something, validate, and go on. So cycle for the design thinking, cycle for the lean startup, prototyping, and after cycle for agile development. And for that, we need a place. So that's what we call the innovation hub. It's a place where we have walls because we need walls to put all this post-it and document together. So that's it for my presentations. Now I can take questions if you have any.
Well, thank you very much. It's very, very different from the style of presentations we have usually, and that's why it was very interesting because the constraints you have, the concerns you have are very, very different compared to what, for example, the finance world would look at. I think you can see on the somewhere that we have a chat and a few people have asked questions. So if you want to look at that.
Yes.
So the first one is, I guess the first one is really the one about POC, spatio-temporal clustering. What is that about?
POC on spatio-temporal clustering. So we were trying to, so we have inside a metro system, we have trips with a lot of people going from different stations across the city at different points in time. So we were trying to figure out if there is a cluster. So we can manually regroup the stations together, saying the stations that are close. We can manually regroup the time together, saying that, okay, we have the morning between 6 and 7, and then a peak hour between 7 and 9. The rest of the day, we have the lunchtime, and so on. But we were trying to see if there is something more different when what we can cluster together. So perhaps some stations can be clustered differently depending of the time of the day also. So it was trying to cluster the trips across a city, across a period by a cluster of locations on time. So for example, regrouping few stations across a specific time. For example, I don't know, perhaps it's 9:45 to 11:12 for these two stations. We have a group of trips that can be put together. On trip is not only one station, it's an origin destinations. So it's more complex because it's dual locations plus time. I'm trying to do clustering on that. So we've done a first algorithm that work so for the moment because we on the time part we tend to have all the trips put together at 1 or 2 points of the day, but not split as much as we wanted initially. So we still need to work on that further. I don't know if that answers the questions. There's a lot of questions about the European program. I don't have more details than that, so I cannot tell you.
I made a quick search on the internet, and the numbers are correct, but it's really part of a very large program, so probably multi-year program.
So what's the difference between the two arrows, slide 43? Let me try to find. Let me reshare. I'm not sure I have the right. Slide 43 is this one. What is the difference between the two arrows? I don't know which arrow you're talking about. These two, between Y and Y?
No, if you look at the very left, you have Y, and it goes up and down, but to the same who.
Ah, yes, it just different people, different different sub-projects. So if you see in details, when you map the target, the different ID we can have, we can regroup them by actors. So it's not individual people, but role, let's say. So we can map what they want by different role on how it will impact their work. So it's a different branch of the same that we repeat for different roles. And then slide 50, what does a small blue circle in the red one represent? Yeah, that it represents the agile, because here we mostly focus on design thinking on the lean startup. And after, once you have through different version of prototype, so when you do a prototype, either you pivot, so that means your prototype is not working. You validate, and it's still a good point. You validate that this idea is not so good, so you document it. You say, okay, this didn't work. Let's try something else, and you move on with the customer to find either another idea on the same to try to fix the problem. Or if you prototype, the first version of your prototype look like promising, you do another version on another versions until you agree with the customer that okay, now it's not anymore a prototype we need, is we just need to get a real solution, because we want to have it working as implemented solutions. And here we are not in prototyping anymore, but more in a project development. And here it's the small circle represents more the agile process that is kind of the same big circle, in a sense that you also do validations, but not anymore of prototype, but of your sprint. Next. So how the collaboration across different business units work? There is some organizations that we call KTD, Key Technical Domain, I think. There's a lot of acronyms, so I'm not always sure of what is what. So yeah, Key Technical or Technology Domain that is across the different business units, and that are in charge of the research part, some funding, but also coordinating the research between units. So the research center are cross, most of them are cross business. So the research center, for example, in Thales Palaiso, I think there is like 500 or 600 researchers. On some of them on AI we talked before, but there is research on materials, research on quantic technology, research on AI, research on robotics. They are all in the same place, and they can work for security, for defense, for transport. So there is these two parts. There is the fact that the research center are cross BL, and the fact that these KTD teams that manage research IDs on some of the budget are also cross BL, so that help to organize. After, there is some lost, or I'm not sure it's lost. Sometimes there is a research team or innovation teams that will do twice the same things, but slightly different. So perhaps it's not so much a loss, but yes, in that case, we are perhaps doing twice the same work, but probably a bit different. At one point, they will converge and decide which one is working the best and which one we need to keep or combine their work together. That make it sometimes difficult. We can have innovation hub, for example, as we do prototype for our customer. We try also to communicate in between innovation hub, but there is sometimes some projects that are done twice, a bit different. The customer are a bit different. They have the same pain, but they don't approach it the same way, and we develop some things twice. But when comes the time to build solutions, usually we can put that together also. So it's not simple. There is some loss, but perhaps it's a price to pay to be able to be close to the customer and progress together. It's not easy, but somehow it works. So the questions about GAN, no, I will not be able to answer you because I'm not working on that directly. So it was, where did I have that? Sorry, too many slides. Yeah, it was in this one. Oh no, I don't even remember which slide. No, GAN, I don't know in which department and for which project it's used. For the moment, we were not doing it here in Hong Kong. So sorry for this one, I cannot answer. Is there some internal wiki with people tagged by their expertise? It's something in progress, not really working. That's the target. So we have HR system cross all Thales, where we can get all the organigram, and we can put in this system skills. But it's not filling properly or not yet. So something that is in progress. We also perhaps too many collaborative tools. We have a lot of chat rooms per topics in a kind of WhatsApp solutions. Not WhatsApp, but an internal one. We have a wiki. Also by subjects, where we can put more fixed topics, text on presentations. So we try to foster some collaborations between teams this way. The chat room is very useful for instant exchange, but nothing is kept. The history is usually lost after 1,000 exchange. You forget what's on the top. So that's why we have also the wiki on the side for something more permanent. For the NASA, no, sorry, I don't have Apollo program reference for that. So that's the slide on the technical readiness level. So the right part here comes from NASA, the way they manage innovations. As Thales have a lot of link to aerospace satellite, it's something we took from them because it's working very well to be able to qualify the state of an innovations. Is something I recommend because it's help communications. Because when you have an idea or prototype, you can give it a rank in this TRL scale, and the people in front know the state you're in. If you are in level 3, you have an idea of what you're doing, but it's not really tried. When you're 6, it's really a prototype that is something that work and that should be pushed further usually. And we have kind of gates where we discuss usually for moving from 6 to 7, for example. And for 3 to 4, so between research, prototype, and product, we have a gate where we put people together that decide if we move to the next step or not.
Okay. I think I'm going to ask the last question, and something we will do before I do that, or after I do that, is that we'll give your details, or we'll make your details available, because I'm sure that people will have further questions later.
Yeah,
I wanted to go... LinkedIn, okay.
Yes.
I had a question again, back to slide number 8.
Wow.
Which is the timeline about all the technologies that you have looked at and used. Well, I had a sort of a general question, because you, as a company, you guys are using a lot of technologies for critical systems. That's something that was very important on the later slide. For critical system, you really want technologies that are proven. You don't want the latest and the greatest. You want something that everybody understands, even if maybe it's not the best, but at least you know its limitations, you know what it does or doesn't do. In the technologies that you see on the slide, do you see anything that's been discarded and in fact is still very relevant? Do you see anything coming back from that?
So I will try. I don't have much detail on some of those. For example, the first one, neural network, 1990. It was widely tried at that time, and it's something that picked up recently because now we have the hardware that can make it run. You don't have to do sampling anymore. You can train your models on your entire data sets. So you also gain some accuracy because of that. So before you have to do a sample of your data, train your model, and use statistics to figure out if it's good enough. You can skip a bit of this part now. So neural network is still very relevant. On the predictions we are working with are a mix of, for example, here in Hong Kong, we are mixing some stat model and some neural network model to improve, to get more accurate predictions. Expert systems, yes, still relevant. I have no idea what is mathematical morphology, so I cannot answer you. Constraint logic programming, yes, still used. Multi-criteria decisions aid, yes. So everything related to a decision systems, they use a lot of this different technology. The multi-agents, here we use that a lot in simulations, agent level. I don't know if it's the same thing here in the PowerPoint, but micro simulations using multi-agent is something we still do a lot. And after, yeah, I think that's what you want to see, because the last one, video analytics, yes, more and more. Information fusions, yes. So used a lot in train autonomy. Fusions of different sensors. So for train autonomy, for example, we have a lot of different sensors. We have radar, LiDAR, video. We have, and we need to combine all that informations. On each type of sensor will overlap and be combined. In case, for example, we lose one, for example, with if we have also the GPS, the GNSS. If we lose the GNSS because we are inside a tunnel, we need to rely on the other one. So the fusions of sensor data is still a very very important nowadays. Yeah.
Well, thank you very much. It's been a very unusual presentation for the meetup, because it's been a lot about not about techniques and what you do as a practitioner, but more about the management, about how to maintain innovation without people going everywhere in every direction and wasting time. So it's been very, yeah, it's been very interesting. I think there are more questions people will have and more interrogations about that. So as Stéphane said, please contact him on LinkedIn. He's going to be available to answer anything. I saw a question about jobs, so
yes,
that's a good one to start with. Okay, well, thank you very much. And I think I'm handing it over to Nathan for the second presentation of tonight.
Okay, thank you.
Yep. Thanks, Stéphane. Can you guys hear me okay?